Welcome back to the GCSE Maths Pro YouTube channel. Today's video is the fourth part of trigonometry where we'll be specifically looking at the sine rule. This part is higher tier only. So first we're going to be looking at how we label the triangle, as we have moved away from SOHCAHTOA now. We're not using right angled triangles anymore. The sine and the cosine rules are for any type of triangle that's basically not a right angled triangle, okay? So we no longer have hypotenuse, adjacent, opposite, all of that. We now just have A, B, and C as the uppercase angles, and then directly opposite each angle would be the lowercase letter. So in this case, we've got angle A at the top, and therefore side A, which is lowercase, will be directly opposite. And as you can see, that works for all of the letters. It doesn't necessarily matter which angles are A, B, and C, as long as you match up angle A with the correct side A, which is opposite. Now, here we have the sine rule. It is just one rule, however, there are two different formats for working out different things. Sometimes with trigonometry we work out sides or lengths, sometimes we work out angles. On your formula sheet you will get one of these, however they won't list both of them. So you just have to know that in the case of sine rule, whatever you're looking for, okay, whatever the question is asking for is what you put at the top of the fraction. So you can see here we have sine rule for sides. Do you see how the lowercase letters, which we know are the sides, are at the top of the fraction? In the case of angles, you can now see that we've got sine A, sine B, sine C. So the angles, obviously angles always go with sin, cos or tan, right? So in this case, they go as sin, are at the top of the fraction. So you just basically take the formula they've got and flip it upside down if it's necessary. As you can see here, I've got a triangle labelled as well. Now, we do have three parts here. We've got two equal signs and three parts. Obviously, equations only have one equal sign, so what you're going to be doing is only ever using two parts, okay? So what I mean by that is, it could be A and B at the same time, it could be B and C, or it could be A and C. It doesn't really matter as long as you've only got two. You're not going to use all three at the same time, okay? So for sine rule, we're going to use it when we've got two pairs of opposite sides and angles, including whichever one is missing. So if you're missing a side or an angle, that's included. For sine and cosine rule, we're going to have four pieces of information. We said for SOHCAHTOA and normal trigonometry, we only had three, didn't we? Again, including what's missing. So you can see here, I've drawn some examples. We have side A and angle A and side B and angle B. If I had those, including, let's say, one that was missing, I would use whichever of these two formulas I need. So if it's for sides, I would use the top one. If it's for the angles, I need to use the bottom one. So for sine rule, the key is I've got two angles and two sides that are opposite each other. In the next video, we'll go through cosine rule. You can flip to that and see what pieces of information you'll be needing so you know when to use sine rule and when to use cosine rule. Feel free to screenshot this page. You obviously don't need to learn the formula because it will be on the formula sheet. However, just in case you want it for your revision, I will have the formulas on each question as we go through. So the first one we have, work out the length BC to one decimal place. So in this case, we're looking for a length. That's why I've given this version of the formula where the lowercase letters are at the top. Those are the sides, aren't they? In this case, obviously, I normally only label the angles, so I'm now going to label the sides that are relevant. I've got, obviously, BC. That's the one I want to find out. That's obviously relevant, isn't it? So which side is BC? Well, can you see how it's opposite A? Angle A. So that side is going to be side A. Okay, and then the other thing that's relevant is going to be, we've got angle B, and then we've got the side opposite that, which would be, therefore, side B. In this case, you see how side C and angle C are not relevant at all. I don't have C as an angle, I don't have it as a side, I don't want to know what it is as an angle, I don't want to know what it is as a side, so it's not relevant. In this case, I'm going to be using A and B as my two pairs. So now I just need to basically just sub it into the equation. So side A in this case is BC, you can call it BC, you can call it A, you can call it X, whatever you want. We don't know what it is, do we? So just call it something as a letter. Over sine of the opposite angle, which is 68, equals side B, which we now know is 20.4, over the angle B, which is going to be sine 32. Now, we do have one step to do with sine rule, with rearranging, because at this point, I can't really type this into my calculator, right? I need to have BC or whatever I'm looking for, whatever I'm trying to work out. I need that as the subject. So can you see how I will have to move sine 68 to the other side of the equation? Now that's just normal rearranging equations. As you can see, it's currently divided by that, isn't it? It's divided by sine 68. So if I want to move it across, I'm going to have to times by sine 68. So my actual equation to find out BC would be BC equals, this whole fraction here is fine, so 20.4 over sine 32 times by sine 68. Now that is what I'm going to type into my calculator, and then we will get our answer for BC. So this is obviously going to be a calculator question. Make sure you have your scientific calculator, not your phone calculator, because that will not work. So I'm going to type in, I've got my fraction, 20.4 over sine 32, just remember to close the brackets in your calculator, times by sine 68 equals. Here we go, that's my answer for BC. So it said to one decimal place, so that will be 35.7. And it's a side, which is in centimetres. And that's your answer. So really, sine rule and cosine rule, all it comes down to is making sure, well, two things. One, that we know whether to use sine rule or cosine rule. That's obviously important. But normally your questions in the exams will only fit into one of those two boxes, right? So once you've seen the second video on cosine rule, hopefully you'll get an idea as to which formula it will fit into. And then just making sure you really label the triangle correctly. After that, it's just a bit of substitution and rearranging. Okay, let's look at the next one. So this time we want to work out angle BAC to one decimal place. So we've got an angle to work out. You can see that's why I've put the angle version of the formula at the top here. So let's see, we want BAC. That's obviously the one with A in the middle. So here, this is our angle that we want. So I'm obviously going to label the side opposite that because that's relevant, isn't it? That's going to be side A. And then in this case, I've got angle C and I've got the side opposite that, which is therefore side C. So for this one, I actually don't need B. Not helpful at all. I'm going to use A and C, and again, you just put them equal to each other. And we just substitute it in. So now that I've done that, I'm going to substitute it in. I've got sine of the angle A, which I don't have, so I'm just going to call it angle BAC, over side A, which is 9.5, equals sine of the angle 56 over 12. And again, I'm just in that same situation. I just need to rearrange this equation to get sine of the angle BAC as my subject. So in the same way we did the previous one, to move the 9.5 across, and we're just going to have to times, aren't I, basically? So even for angles, it's kind of the same idea. So my fraction is still fine, sine 56 over 12, and then I would times that by 9.5. And at this point, we just get our calculator. So fraction, sine 56, close the bracket, remember that. Otherwise it might give you an error, times by 9.5. Now, you get this answer, which, considering we're looking for an angle, it's clearly not 0.65 degrees, is it? Let's just be honest, that's not realistic. This is very similar to when we did SOHCAHTOA. When you're trying to work out an angle with trigonometry, whether it's SOHCAHTOA, whether it's sine and cosine rule, you're always going to have to do sin inverse, because you see how here I've got sine of angle BAC equals. That's not just angle BAC, is it? That's sine of the angle. So I'm going to have to do sin inverse. So when we do shift and you press the sin button, you see you get the -1. Press your answer to copy all of those decimals. Do not round it too soon. Equals, now do you see it's seeming a bit more realistic, isn't it? 41 degrees. I think, yeah, that's a bit more realistic. 41.0 degrees to one decimal place. In this case, one decimal place, I know it's 0, seems a bit pointless, but it does say one decimal place, so you have to put the 0. It has to be at least one decimal place. Okay, so that's 41 degrees. So just remember at the end to do sin inverse, or in the case of, if you're doing with the cosine rule, cos inverse, whenever you're working out an angle. If you want, you can do sin inverse all of this at the start. That's fine. If you're happy to do that, that's absolutely fine. If you want to do it at the end, also fine. Just remember to look at your answer and go, does that seem reasonable? Does 0.65 degrees seem reasonable? Clearly not. So we need to do something extra. Otherwise, the method is basically exactly the same. Okay, let's have a look at another one. So we're back to working out a length. So work out the length of AB to 3 significant figures this time. Again, I've got the side version of the formula. I want to start by labeling my sides that I think are helpful. So AB, that's helpful, is now I want to know what AB is, so I need to label that. That one is opposite C, isn't it? So that's side C. Okay, so we're already looking to use angle C and side C. I've got both of those, as in one of them I want to find out and one of them I've got. Now, if you have a look though, we do have another side and another angle. However, they're not opposite each other, are they? For example, angle A, which is 17 degrees, is opposite side BC, and we don't know what side BC is. So that's a bit useless, isn't it? And then side AC is opposite angle B, which we also don't have. Now, I've seen this a lot where you're kind of thinking in terms of sine and cosine rule, and this is like, what, grade 8 stuff, I guess, and you're thinking of all this kind of really complex stuff. That we get to this point, we get a bit stuck, and we forget about something really basic information, really basic calculation to help us. I've got side AC. It would be easier for me to work out angle B than it would for me to work out side BC. How do I work out angle B? And everyone goes, oh, I have absolutely no idea. Because we're just thinking too much about sine and cosine rule, right? Just think back to basics. This is a triangle, ultimately. All triangles add up to 180 every single time. So I just have a little extra step here. Nothing to do with sine rule or cosine rule or anything like that. Nothing to do with trig, just to do with angles. To find angle B, I need to do 180 minus the other two angles, right? And that sounds really simple, but a lot of the time, because we're thinking of something so complex, we just kind of forget about the really basic stuff. So just look out for that. If you get this in a question, you think, right, I've got two of each, but they're not opposite each other. Just think, right, can I work out the third angle by taking it away from 180 if I've got the other two? Sometimes that happens. Okay, so actually angle B is 68 degrees. Now that we have that, angle A is not really helpful, is it? I've got angle B and I've got side B. There we go. So those are the two I'm going to be using. I don't need A. And now we carry on as we did before. Just write it out into the formula. Side B is 6.3 over sine of the angle B, which is 68. And then we want side AB, which is over the angle C, which is 95. Okay, same exact thing, I just need to get AB on its own. In this case it is on the right hand side, that doesn't really matter, you can write it in the other order if you want. I'm just still going to times across by the sine 95 denominator. So my calculation will be 6.3 over sine 68 times by sine 95. 6.3 over sine 68 times sine 95, again close all the brackets, there we go. Now, because this is a side length, I don't need to do a sin inverse or anything, that is just the answer. But double check, I've got AC as 6.3, does 6.7 seem like realistic? It's in the same realm, right, of possibilities. Yeah, it seems fair. So AB, to three significant figures this time, is 6.77, and there's our answer. So just double check, you might have to do a little step before you get to sine rule or cosine rule. And don't forget these basic things about angles and triangles and all of that. Okay, this is our last question. They might make it a little bit harder because ultimately it is just substituting into a formula that they give you, right? So they might try and make it a little bit harder by sticking two triangles together. So again, I know I'm not using SOHCAHTOA because none of these are right angle triangles. They're both effectively scalene triangles. So I know I'm going to be looking at sine or cosine rule. In this case, we are practicing sine rule, but I've got two triangles. So it's likely I'm going to have to do two steps instead of just one, two sets of working out. So let's see, we want to work out the angle ADC, which is this one here. It's always the middle letter. Now, if you have a look at triangle ACD, okay, this bottom triangle, I've got two pieces of information plus the one I'm missing. That's only adding up to 3 pieces of information, but remember we need 4, including obviously the missing one. We need 4. So currently in triangle ACD, I don't have enough information. Hence why I need to look back at triangle ABC, see if there's anything I can work out there to then help me with the second triangle. Normally, let's be honest, it's going to be the side in the middle because they both share that side, don't they? But let's have a look. So we've got angle C and then opposite, we've got side C, so that's a pair, isn't it? That's good. And then we've got angle B and opposite that is the side that they share. So I could use my first triangle on the left to work out an extra side, which I can then use in my second triangle. So this is now split into 2 steps. Step 1, we're finding out side AC effectively, isn't it? Side AC. Okay, so AC over sine of the angle B, which is 85, equals 8.8 over sine of the angle C, which is 59. Again, obviously, you know you need to times it across so that you can get AC as the subject. So 8.8 over sine 59 times by sine 85. That's going to go in my calculator. Okay, now I know it says to one decimal place, however, this is not the final answer, is it? So what I'm going to do is keep my answer there in my calculator, don't clear it or anything. I'm going to write down a couple of decimal places, but don't round it too soon, otherwise you might get a slightly different answer. So it's kind of like ... isn't it? So I know this is now 10.227 ... isn't it? But at least I have this side. Now I can look back at my triangle ACD because I now have 4 pieces of information. I've got side AC, I've got side CD, that's 2, I've got angle A, and I want to find out angle D, so that's 4. I want to find angle D, so I need the opposite side, don't I? Now in this case you can see we've got angle D, which is not necessarily one of the letters in the formula. You can choose to change it, you might want to call it B, because you've got A and C still. Or if you're happy to use D, just know that obviously opposite that, the opposite side is side D. Okay, just know that those two go together. You can always scribble them out and change the letters if you want. It's completely up to you, make it work for the formulas. And then we've also got angle A, and therefore that has to be side A because it's completely opposite. So in this case I've got A and then I guess D. Wish we could call that one D. There. So now step 2, we do exactly the same thing. Obviously now I'm looking for an angle, so I've got the angles at the top of my formula. So let's do sine ADC over, now I'm writing down 10.227. Obviously in my calculator, this is where I would use my answer button, okay, to copy all of the decimal places. And then sine 41 over 15.4. We obviously have to times it across so that I can put it all into my calculator. And because we're trying to find an angle, just don't forget that this one, we're going to want to do sin inverse. So you can see I've still got my previous answer there. I can clear it, but it will still be in my answer button. So I'm going to put in my new formula. And then when I press times, I'm actually going to put answer. Okay, I'm not going to type in 10.227, right? Because it's missing decimals. I'm going to put answer. Just make sure your previous answer was the same one. Again, we've got an answer that's clearly not 0.4 degrees, so I need to do sin inverse of my answer, which is actually 25 to one decimal place, 25.8. So angle ADC is 25.8 degrees. That seems more reasonable. So there's my answer. I basically just had to do the same thing twice. Okay, sometimes that will happen. You get 2 triangles stuck together, you know you're going to have to do sine or cosine rule twice, or one of each maybe. So that is everything on sine rule. The next video is going to be cosine rule, which I will link here. Thanks for watching this video. If you found it helpful, please make sure to like and subscribe, and let me know down below if you have any questions or comments.